right, just a reminder again that we have an exam on Monday. I got a review sheet here as well. We'll talk a little bit about the exam after we finish up the section 2.6 stuff. This is one review sheet. There's an additional one on Moodle as well as a practice exam. So you've got 3 different things that you can review from for the exam. Also, remember that Hope sold the review session 1 on Sunday. And you have office hours today. Yep. 1 to 2. Yep. So Hope has office hours today 1 to 2. And is holding a review session in the Math Center from 1 to 3. Or 1 to 1 o'clock. Also, Math Center hours for Sunday have changed. Just for this Sunday, it'll be 1 to 3. It'll be open. So if you're done with the review session, we want to hang around and ask you more questions. There will be tutors there until 3 o'clock. It will not be open at 6 on Sunday like it typically is. So make sure that you plan accordingly if you're planning on going to the Math Center this weekend. All right. Any questions at all before we finish up section 2.6? All right. Well, let's do a couple more examples of transformations. In particular, there's one transformation we haven't done yet, which is your horizontal stretch or compression or reflection. I haven't done horizontal ones yet. We've done the horizontal shifts. So we'll do a couple examples of those. All right, so let's do this next one. We've got g of x is 2 times root negative x plus 2, and then minus a 3 on the end. Again, first thing you want to do is identify a base graph. What do you think we want to use for the base graph on this one? Square root of x, right? Do that one first. Oops. What does square root of x look like? Yeah, good. It looks like, yeah, exactly. It looks like that, doesn't it? Starts at the origin and goes up to the right slowly. Notice that your x squared looks like that, right? The right-hand side goes up that way. Square root of x is kind of the reverse of that. All right, so start here at the origin, 1, 1, 4, 2, 9, 3. It goes that way. All right, so now notice that we've got some things going on. 3 of them we've talked about before. There's one extra one that we haven't done yet, and that's that negative sign, right? So that 2 on the outside, what's it going to do? It's going to vertical stretch, right, by a factor of 2, right? That minus 3 on the outside, shift it down, right? So both those are on the outside, so it'll affect the outputs, right? One's a stretch, one's a shift, right? Now, for the inside, when you've got these coefficients on x, and you'll see one in the next problem as well, what I would do first, since I talked about last time about going from left to right as you do your transformations, what I would do first, anytime you've got a coefficient on the x on the inside, the first thing I would do is factor it out on the inside. That would be my first step. So I write this as negative x minus 2 and then plus a 3. The reason that I do this is because this allows me to do my transformations from left to right as I see them. Yes. Oh, this should be minus. Sorry. Thank you for catching that. I can get it. No, let's just erase the whole thing. Again, if I factor that off, first, if there's a coefficient on the x and I factor it off first, it'll allow me to work from left to right to list out the transformations and do them in that order. Okay. If you don't factor it out first, you've got to reverse the process of the inside as opposed to the out, which makes it a pain. Personally, I think it's a pain. All right, so now we should see what this -2 does. We talked about what the minus does last time. What's that going to do? It's going to distribute which way? It's going to shift it which way? To the right. Good. Right? Because it's a minus. It does it kind of backwards on the inside. Right? So this will go right too. Now, when we had a negative on the outside, what did the negative on the outside do? It flipped it upside down, right? Because it affected it vertically. This negative's on the inside now. So instead of going vertically, which way do you think you're going to flip? Horizontally. Good. So here are your transformations. That first one is a vertical stretch by a factor of 2. The second one is a reflection about the y-axis, because you're going to go left, right, rather than up, down. The third one is a shift right, 2 units. And then the fourth one is shift down, 3 units. We okay with listing those off that way? When you see one on an exam, that's going to be the first part, is to list the transformation. Okay. I know it can get a little dicey when you actually try to apply them on the graph. That's why I wanted you to list them out, because I want to know what the issues are if the graph doesn't match what it's supposed to. Okay. Make sure you've got them identified. Try to give you as much credit as I possibly can on that problem. Right? Okay. So make sure you're able to list them out like this. All right. All right, so now let's do it step by step. And that's why I've also identified some points on here. The first thing is stretch it by a factor of 2. Well, the one at the origin stays at the origin, right? But this is going to go from 1 to 2. Instead of at 2, it'll go up to 4. Instead of 3, it'll go up to 6. And so you get that for step 1. Next part. What is it? What's the next transformation we see? That reflection, right? So we're just going to flip-flop it right to left. So instead of being at +1 for x, we'll be at -1. Instead of being at +4 for x, we'll be at -4. And instead of +9, we'll be at -9. 5, 6, 7, 8, 9. That's where I was right. So it should look exactly the same as the previous step, just flipped over to the left. And hopefully yours is not nearly as wavy as mine is. So far, so good. Next one is everything goes which way? Right 2. Yeah. So this one will go over here. This one goes right where that red one is, doesn't it? Okay. This one goes here. That one goes here. And we got... I could draw without my hands shaking as I go on the screen. I'd be a lot better off. And then lastly, what do we need to do? Shift everything down 3, right? So the green one goes down 3 units. So down 3 units is here. 3 units is here. 3 units is 1, 2, 3 here. 1, 2, 3 here. And again, it should have the same shape. Just shift it down. And so this one's the final. Are we okay with the process? Say that again. And you know, I come into a shit. So one of the reasons I put those points on there is that helps me identify those ones. So I'm just taking each of those and shifting them that way. Yeah. All right. Was it? Yep. All right. Work on the next one for a minute. I know you're going to come across an issue with that 3. So see if you can get the transformations listed down besides what that 3 is on the inside. But make sure you factor it off first. The same idea, okay? So just get the transformations. We'll do the graph in a second. I'll talk about what the 3 does, but do the other ones. Identify your base graph and identify the other transformations. Work on that one for a minute. But we'll talk about what that 3 does on the inside here. So don't worry about writing that one down yet. Okay, but do the other ones. Ready to chat about it? You? Okay, what did you do first? What did I tell you to do first? Yeah, factor out that 3, right? Okay. So hopefully you were able to identify the base graph. What should be the base graph here?
Root of X.
Yeah, cube root of x. Good. Okay. Now notice I've got 5 numbers here. Hopefully you guys identify that there are going to be 5 different transformations that go on here. What's that negative do?
Reflection about the x-axis.
Yeah, reflection about the x-axis, right? That'd be number 1 there. Okay. And again, notice that when we have it written this way, I literally am just going left to right. So this is reflect about the x-axis. I almost wrote the wrong one there. X-axis. Then what does the 4 do here?
Vertical stretch.
That's a vertical stretch by a factor of 4, right? Good. We okay with those two? All right, let's skip the 3 on the outside that of the parentheses there. Let's do the plus 3. What does the plus 3 do here? So what? This is an addition. It's going to be shown to the left, right? It goes backwards on the inside, right? So it's going to go left. How far? 3. Good. I'm going to put that in number 4. And I'm going from left to right here. And then finally, the minus 2 on the end. Shift down. Okay. Are we okay with identifying those 4? Those okay? I know I missed. I know I skipped one. But the other one's okay? I skipped that one because we haven't talked about that one yet. All right. So remember when we talked about the shifting, on the inside it does kind of the opposite of what you expect it to do, right? Pardon me. When we subtracted on the inside, it moved it in the positive x direction. When we add on the inside, it goes to the negative x direction. Right? Okay. On the outside, we had that 4. And we said we did a vertical stretch by a factor of 4. Right? Now I've got a 3 multiplied on the inside. Rather than being a stretch, this one's going to be a compression. It's going to be the opposite of what you would expect. Right? So this is going to be a horizontal compression. Pardon me. A horizontal compression by a factor of the reciprocal, so 1/3. It's going to be smashed in. It does the opposite of what you would expect. Okay? All right, so what does your cube root graph look like? It's like a sideways S, right? It goes like so. That was our base graph? Ish. Yes. I like to think of my compressions as being 1/3 as wide, so it's getting smashed in. That's why I did the reciprocal. Because it's not as been smashed in 1/3. Let's put it that way. All right. Pardon me, goodness. So the first thing we do is what to the space graph? Reflect it, right? So it's going to go that way. And then we're going to do a vertical stretch by a factor of 4. So all your outputs get multiplied by 4. Well, the 0 doesn't change, but this is at 1. So instead of at 1, it'll be at 1, 2, 3, 4. All right? Or I wanted to 5, didn't I? 1, 2, 3, 4. Over here, this would be the point at negative 2, 8. Sorry, try that again. Negative 8, 2. I said it backward. Negative 8, 2. So it'll go up to 8. 3, 4, 5, 6, 7, 8. This one will be down at negative 4. And over here we'll be down at negative 8, 5, 6, 7, 8. So we have, whoa, I missed. We have 4 times as tall. Just taking your outputs and multiplying it by 4. So far, so good with those two? Those look like ones we've done, right? The reflection and the stretching. The next one's one we haven't done yet, and that's that horizontal compression. The way I think about it, and this is another reason why I did by a third, is rather than multiplying everything by this number, you're going to divide everything by this number. Okay? So you'll take all of your x's and divide it by 3. Okay? So this x over here is at 8, so I'm going to move it all the way over to 8/3, which is 2 2/3, negative 2 2/3 in this case. Bless you. This is at -1, so we'll move it to -1/3. That's at +1, so we'll move it to +1/3. This is at +8, so we'll move it to +2 2/3, which is about right here. So we get something that's smashed inward. I'm not looking for perfection. I'm just looking for that you are communicating the idea. Okay? So we've got it flipped upside down, stretched upward, smashed inward. Right? Those are the first 3. The next thing we do is what? Left 3. It should have the same basic shape, just shift to the left 3 units. So instead of being here at the origin, we'll move it 1, 2, 3 units to the left. Change my color here. Here. And then this green dot here will go over here. 1, 2, 3 units here. 1, 2, 3 units. And 1, 2, 3 units here. So should be that one. Not great. I'm not looking for perfection in your pictures, just the idea. And then finally, what do we do with the last one? Everything goes down 2, right? So this will go down 2. This one will go down 2. Down 2. It's harder to see on this one because it's just not a great. It's not shift. It's so stretched out. It's harder to see. But again, should look about like that. Should be the same basic shape, and so that's the last one. I know my picture's ugly, and that's okay if your picture's ugly. That's why I want you to list out the transformations, and I just want to make sure that you understand the idea of what's supposed to be going on. What questions do you have? Yes.
What made it a reflection of the x-axis?
What's that?
What made it a reflection of the x-axis?
The negative out in the front. This part right here. Yeah. Anytime you see a negative sign multiplied by it, it's some sort of a reflection. So a negative on the outside is an up-down, which is why it's not the x-axis. A negative on the inside is left-right. Okay. All right. So in the next ones here, it's basically asking you to the reverse direction. Rather than giving you the function and identify the transformations, it's telling you what the transformations are, and you're supposed to write the function down. Okay? So this one says start with a square root function. Stretch it horizontally by a factor of 3. Reflect it across the x-axis and move it up 2. Let's ignore the horizontal stretch for the time being. We'll come back to that one because that was the newer one that we just did. We'll come back to that. But let's do the reflect about the x-axis and move it up 2. If it's going to be reflecting about the x-axis, how do we handle it? How do we put in a reflection? What do we use? A negative. If it's going about the x-axis, should it be on the inside or the outside? Outside, because it's affecting the y's, right? That's vertical, right? So I should have a negative outside my square root. Okay? We'll do something on the inside here in a second. Move it 2 units up. How should we represent moving 2 units up? A +2 on the outside, right? Good. Because that's a vertical one, right? Okay. So far, so good? Okay. The only other thing that we haven't talked about yet is that stretch by horizontally. Okay. Now let's go back to the previous example real quick. Notice that we said this 3 did a horizontal compression, right? And we said it was by a factor of 1/3. It was flipped, correct? So if I want to do a horizontal stretch, what do we think we want to multiply by on the inside?
Would it be x over 3? Or
It'd be good, exactly right. It'd be x over 3. We want to do a 1/3 of the x. It's the reciprocal. Okay. When you want to do a stretch horizontally, it's flipped upside down again, right? It's doing the opposite. So if I want to stretch by a factor of 3, I'll multiply by a 1/3. Okay? Because I know it's a little bit trickier. Let's do this last one. Start with x to the 4th. Compress vertically. Reflect at the y-axis. Move right 2 and down 3. Let's see if we can handle them case by case here. Compress vertically by a factor of 1/2. What should we do? We're doing vertically this time.
So outside, just go down.
Yeah, outside and just a 1/2. Good. If it were compress horizontally, what would we do? If it said horizontally rather than vertically? Put a 2 on the inside. Yeah. It's the opposite, right? So if it's on the inside, it's the opposite of what you think it should be, right? Okay. All right. Reflect with the respect to the y-axis. Reflections we do with a negative. If it's about the y-axis, go to the inside, right? So we'd have a negative on the inside. Move it right 2 units. So what should go inside those parentheses there? X -2. Good. And then finally, down 3 units should be -3 on the outside again. Good. Again, when you've got those numbers on the inside that need to be multiplied, whether they are negative signs or actual honest to goodness numbers besides the negative sign, make sure you put parentheses around the part that's getting shifted. Okay? Questions on that at all? Okay. Let's chat a little bit about test. Let's see if I can pull up the practice test real quick. Now, of course I have to do my 2-factor authentication. Why wouldn't I? We haven't done that in the last 5 minutes. Let's do it again. All right. College algebra. Yes. Yes. Yep. Yes. All right. So here's the practice exam I posted on here. I'm just going through the different types of problems because these are test problems that I asked last semester, as a matter of fact. Okay. So give you an idea of what a test looks like. So notice this one. Got a couple of different things. Figuring out if something is a function or not. What do you use? Vertical line test, right? So this one is Not a function. Good, good. All right. Next part is domain or range. Domain, what do you look for? Yeah, the things you put in. So you're looking at the x's, right? With the x's that are taken up in your graph. Range, you're looking for the y's. You had a problem on the quiz like that, right? On a noodle quiz, as a matter of fact, I believe. This was on a Moodle quiz as well, right? This one's got a couple of graphs given to you and then asking you to solve equation and inequalities. For any of those, what's the important points that you're looking at? Where they cross, right? So the important x values here are going to be -3, 1, and it's like 5 over off to the right, right? Now the important part, not for the equation, but for the inequality, is you got to figure out which graph is which, right? And we talked a little bit about how to figure out which graph is which based on that leading coefficient piece, right? Let me see if I can zoom in a little bit here. That leading coefficient piece, the part that's the highest degree term, this one has an x cubed, so it has to look like an x cubed graph. How does an x cubed graph go? Is that one, right? So in this case, it's the green one, right? This is going from lower left to upper right. So the other one must be the x squared graph. What does x squared look like? Like that, right? Which we see that's the blue, purple, whatever color that is. Does that make sense? Okay. Make sure you can identify which is which so that you can solve the inequalities. This one's giving you a function and asking you to figure out the domain based on what the function is. We've had two big issues when determining domain. What were the two big issues? Can't divide by 0 is one big issue. Yeah, can't have a negative under the square root, right? Those are the two big ones. Which one applies here? Negative under the root, right? So you need what's under the root to be greater than or equal to 0, right? That's how we would solve that one, okay? But remember, there are two issues, right, that we have to look for domain. So don't forget about the one with dividing by 0, right? Make sure you don't do that, okay? Difference quotient problem. What's your whole goal when you're doing a difference quotient problem? Get rid of the h in the denominator, right? Okay. Let's do one like this one, so I'll leave this one for you for practice just to make sure we're all on the same page here. Go off to the side here. Let's say your f of x is, let's say, negative 3x squared minus 2x plus 5. Pardon me, goodness. Again, when you see f of a plus h, what does that tell you to do? Plug it in for x, right? So I'll have negative 3 times the quantity a plus h squared minus 2 times the quantity a plus h plus a 5. That's the first part, right? What's the second part going to be?
The denominator.
Well, I got a denominator, but what's the second part in my numerator going to be? Good. So the first part's when we put in a plus h for x. The second part's when we put in a for x, right? Yep. Yep. Want to go all the way, because again, our whole goal is to do what? Get rid of the h. That's the whole goal of these problems, right? Is cancel out the h. Okay. What do I need to do next? Yeah, I need to multiply everything out, right? Okay. So if I just do a plus h squared, if I do this up to the top, what do we get when you do a plus h squared? Good, that's right. Remember, don't forget you have to distribute everything, right? That's a plus h times a plus h. Over here, I want to take that and multiply by -3 all the way through, right? So this will be -3a squared minus 6ah minus 3h squared. Because I got to take the -3 times that whole thing. Right? This part's going in right here. We also need to make sure you distribute your -2 through. And then notice I've got these brackets around the second part for a reason. That minus sign has to apply to everything here. So I got to distribute in my minus sign as well. So you get plus 3a squared plus 2a minus 5. Okay. Now again, I know I've said it twice already. What's our goal? Get rid of the h, right? In order to cancel out the h, I need to factor an h out of the top, right? I can't cancel an h until I factor one out. In order to be able to factor out an h, anything that does not have an h in it has to go away. Okay? We have to factor an h out to cancel, so I can't have anything left on top that has an h in it. Okay? So for example, this minus 3a squared doesn't have an h. Does it cancel? Yep, right there, right? There's something that cancels it out, correct? What else doesn't have an h? The 5 doesn't? Do those cancel? Yep. And what else? The 2a's. Do those cancel? Yes. That needs to happen every time. Okay? So here, the 3a squareds go away. The 2a's go away. The 5's go away. Everything left, that's this term, and that's this term, has an h in it. So we can now factor out an h. What are you left with when you factor out an h? Good. And then finally, we can kill the h. And we're left with -6a minus 3h minus 2. And that's provided, of course, that our h wasn't 0 to start with. Why don't we want h to be 0 to start with? Because you can't divide by 0. Yeah, exactly. Is this okay? Yeah. So again, remember that your whole goal of these is to try to eliminate the h in the denominator. So we got to do some simplifying. In particular, when you've got ones like this, anything that doesn't have an h must cancel. If it's not canceling, you've done your arithmetic wrong. Okay? Go back and check it. All right, let's switch back over here. We got a piecewise defined function. So which piece would the 0 go into? The top one. The 3 would go into, and the 1 would go into the top one, right? And then this last part's asking you to graph it. So I need to graph, what kind of a shape is -2x plus 1 going to be? A line, right? It's going to be a line, slope of -2, y-intercept of 1. Make sure you stop at 1 when you graph that one. Okay? And then x squared looks like parabola. It's a U shape, right? And then we would take that U shape and shift it up 2. Yeah, so you have that U shape shifted up 2 for the other part. Okay. I don't think I have the answers. I'll get the answers posted to these later this afternoon. I forgot to post the answers when I did this earlier. My apologies. Here, you've got a graph. This looks like one that you just had on the quiz as well, right? For increasing, you're looking for where it goes up and to the right. And we're looking for intervals of x values, right? Okay. So here we see it goes up and to the right from -4 to 1 and 5 to infinity. And then for decreasing,
Negative infinity to -4.
yep.
And 1 to 5.
And 1 to 5, and there aren't any constant intervals, right? Okay. local max 1.6, local min 5. Good. The bottoms of those valleys, right? Okay. Like I said, we just had one like that on the quiz, didn't we? When the problem asks you to express something as a linear function, that literally means to do what? Yeah, make it y equals something, right? Solve for y. So again, when it says express as a linear function, just means solve it for y, right? That's all it means. This one has function that goes through a point and is perpendicular to a line. What do we know about slopes when they're perpendicular lines? The negative reciprocal, right? Flip it upside down and switch the sign. Okay? And then we find the y-intercept by using our point. Right? We've done problems like that. And we did problems like that definitely when we're doing the linear model problems, right? Okay. And there's a linear model problem. Okay? Shockingly enough. Charge per mile. In your linear model, the charge per mile in this case, remember again, we're trying to find slope and y-intercept. Charge per mile in this case would be which one? The slope or the y-intercept? The slope, because it's something per something, right? It's a fraction. Okay? So it'd be your slope. Notice in this case, the part B says, what is the flat fee? That's asking for the y-intercept, right? Okay. And then finally, this last part says, how many miles can you drive for $120? Going back up here again, you're putting in miles and getting out dollars, right? So that's the y value, right? So you're solving for an x. Yep, exactly right. And then finally, this last part's just the transformations like we were just doing. So what transformations do you see here? This negative sign would flip it over the x-axis, the 1/2. Compress vertically, the -3. Right 3, the -1. Down 1. Yeah, good. Should not be a surprise on what kind of problems to see on the exam. Okay? This literally is what I gave last semester. Okay? So you've got 2 reviews. One I handed out to you in class. You've got a second additional review posted on Moodle. There are answers to both of those as well. Practice exam is on Moodle, and I'll get answers to that posted. I forgot to do that when I posted the practice exam. I apologize. I'll get that done this afternoon. So you have it. Hope's review session, 1 o'clock on Sunday. You also have office hours today at 1 o'clock, 1 to 2. Okay? All right. Have a good weekend. Enjoy the Super Bowl. See you Monday.
Me and you literally just go over it.